Hey, what's going on guys? Tanmay here for Simple Snippets. Welcome back to another video tutorial on data structures and algorithms. Let's continue with our graph implementation topic. In the last few videos, we've started with the implementation, which means we are going through one operation at a time and trying to write the C++ code for that operation in the graph implementation. So if you've watched the previous few videos, you're good to go. If not, this video is going to be difficult for you to understand. So please make sure you watch the entire graph implementation topics. I have them organized properly in this DSA playlist. Do check it out. And if you watched the previous video specifically where we did the update edge operation, things are going to be pretty much exactly the same in the delete edge operation, which we're going to do today. And there is only going to be one or two lines of code that is going to change. Okay. So if you watch that, this video is going to be a breeze. It's going to be much more faster to understand. So we'll move ahead at a faster pace as well. And again, to understand this particular function or operation, it's very important that you understand our approach, the graph data structure as a theoretical concept as well. So make sure you watch the previous few videos in this playlist. And with that being said, let's get started. So as the title of the video suggests, today we are going to do the delete edge operation. So delete edge is nothing but deleting an edge between two vertices of a graph. Okay, pretty easy to understand. So our task is to delete an existing edge. And on the right hand side, you can see our graph. This is the graph that we're going to take as an example. And we are going to delete this particular edge. Okay, so there is an edge between MH and MP. So this MH stands for Maharashtra. In fact, one entire vertex is depicting a state in India. This is the use case that we have taken for our graph topic, and that this is what we are going through in this entire course, in this entire graph topic. So we have a state code. MH stands for Maharashtra. We have the state ID. We have the edge list, which is this green box inside every vertex. So this pink box is the entire vertex. Inside that we have three data members: the state ID, the state code, the edge list, which will keep edge objects. So the yellow boxes are edge objects which denote one particular edge between a particular vertex. Okay, so 2,500 stands for a edge between Maharashtra and Goa. 2 is the destination vertex ID for Maharashtra. So Maharashtra's ID is 1, so MH is 1, and 2 is nothing but the destination. Whose ID is 2? You can see Goa's ID is 2, that is GA, hence the destination vertex ID, and the 500 is nothing but the weight. Okay, so weight of the edge, you can consider it as in kilometers, that is distance between the two states. So these are the assumptions that we've already made, and you guys should know already because this is what is happening in the previous videos as well. So not going through the basics of it, but yeah, the idea is to delete one of the edge. Okay, so that's why we're making the assumption that there exists a graph with three vertices and these two edges, and we want to delete this one. Okay, now another thing to understand is that since our graph is undirected, it would mean that if there is an edge between Maharashtra and MP, it would also mean that that same edge represents the other direction from MP to Maharashtra, right? So this one single line means both way communication or both way travel, which means that in the Maharashtra's edge list, we will have one edge representing the edge between Maharashtra and MP. Similarly, we will also have one edge object in the edge list of MP, which also represents the same. So when you want to delete this edge, you want to delete this object and this object programmatically when you talk about implementation, right? Because ultimately we want to write C++ code. So in the coding perspective, we want to delete this object as well as this object. Only then you can say that this link is broken, this edge is broken. Okay, all right. So this is our initial assumptions and the things that we are going to take into consideration. On the left hand side, we have the entire delete edge by operation. So we have delete edge by ID, similar to what we had when we were doing the update edge operation. We had update edge by ID, and the name itself suggests that we're going to pass IDs of from vertex and to vertex. So in this case, we are going to pass 1, which stands for Maharashtra. The two vertex is going to be 3, which stands for MP. And of course, here we do not need this new weight. So in update edge by ID, we needed to update the weight. So we had to pass the new weight. Over here, since we do not want to update, we want to completely delete it. So this one particular argument is not needed, right? So let me quickly erase this off. Okay, so from vertex, I've written it over here. It's going to be 1 for Maharashtra. To vertex is going to be 3. Now it can be vice versa. You can give from vertex as 3 and to vertex as 1, because as I said, our graph is undirected, so it doesn't matter the source and the destination, because ultimately we want to delete the edge, which means that we want to delete the edge object in the edge list of both these vertices, right? So just like what we did in update edge by id, the first thing that we do when you go inside this function is make a check and check if edge exists by id, which by the name itself it means that it is going to check whether an edge already exists or not. So again, from vertex and to vertex IDs are going to be passed 1 and 3, and currently there is an edge between Maharashtra and MP, which means that this function is going to return true. Now we've already discussed check if edge exists in previous videos, so that's why I'm not covering this function. This is again our own user defined function. So this will return true, and if the check is true, which means there exists an edge, in that case this entire if block will be executed, and inside this if block, this is the entire code, right? Now in case if this check variable was false, it would mean that there is no edge between the two vertices, and in that else part we will simply print edge between from vertex and to vertex does not exist. Okay, but currently the check is true because there exists an edge between Maharashtra and MP. So now we are going to execute the if part. Now inside this we will go in a loop, because we want to iterate through all the different vertices in the graph, and we only want to particularly select the two vertices, which is from vertex and to vertex. So how do you find out from vertex and to vertex? From its IDs, right? Because these IDs are unique to this graph, which means that only one vertex will have only one unique ID. So if Maharashtra is having 1, Goa cannot have 1, right? That is our implementation. So in the loop, we will say we will start from 0 to vertices.size. Now this vertices is nothing but a vector. A vector, you can consider it as a dynamic array. It comes from the STL. So we've named it vertices, and you can assume it as a dynamic array. So what this vertices is storing? It is storing individual vertexes. So at index position 0, we have one vertex, which is this one. So programmatically, this is how it would look like in memory, and this is for visual representation, but both of them are the same thing. So at index position 1, we have the second vertex. At index position 3 or index position 2, we have the third vertex, and indexes start from 0. So we are looping from 0 to vertex.size or vertices.size. Currently the size of vertices is 3, right? Because it has 3 elements or 3 vertexes. So we will go from 0 to 3, which means we will go from 0, 1 and 2 3 times, right? So the first outer loop is going to loop for 3 times for these 3 vertices. Now out of these 3 vertices, we are only interested in Maharashtra and MP, because the edge is between Maharashtra and MP and we want to delete that. So this Goa doesn't come into this picture, right? So that's why we have to also make that check. So in the outer loop, once we get inside the loop, so let's say for the first iteration, that is the 0th iteration, let's say I equals to 0. We will check if vertices at I, we just said I is 0 for the first looping iteration. So let's say if vertices at 0 get state ID is equal to from vertex. Now this is where we check the indexes, because we are only interested in Maharashtra and MP, right? We are not interested in Goa. So when you say vertices.at, you can see vertices.at 0 is nothing but Maharashtra. So this at function is nothing but a predefined function which comes with the vector class. Okay, so vector is not our class, it is already pre-written in STL, and a class always has some data members as well as some member functions to use. So at is one predefined function which we are directly using, and it gives an object or an element stored at a particular index, because vector is nothing but a dynamic array, right? So it will store multiple elements at indexes, and when you want to access a particular index, you use this function. So at 0 we will get this first object, this entire first object we will get, and then we say dot get state id. So get state id is our user defined function which, as the name suggests, will return the state id of the vertex at this particular position. So at 0 position we have this vertex. What is the state id? It is 1. So we will get 1. Is 1 equal to from vertex? From vertex is 1 that we are passing over here. 1 and 3 is going to be passed. So yes, 1 is equal to 1. Now this if is true, so we will go inside this if block and we have one more loop. So the second loop, that is this inner loop, is used to iterate through this edge list. So we found out our first vertex, correct? We found out the from vertex. Now we have to go inside this vertex, inside the edge list of this vertex, and delete one particular edge object, not both, because 2,500 represents this edge and 3,700 represents this edge. So we only want to delete this one. So we will have to iterate through this edge list also, because every vertex has its own edge list. So this loop is for that, and this loop will say it equals to vertices dot at I dot edge list dot begin. Now this is a big instruction, but what basically it is doing is we are creating a auto variable it. Let me write it over here, it, and it is going to act like a pointer, and it will point to the vertices dot at I is still 0, so vertex is at 0, so we are pointing to the very first vertex, dot edge list. So as I said, every object, every vertex has its own edge list. This green box is the edge list, the inner green box. So this green box is basically the edge list, and when you say dot begin, it would begin from the very first element inside the edge list. Now inside the edge list we have these yellow boxes which represents one edge object. So edge list is nothing but a list object, which again comes from the STL. We've discussed about it previously. List is kind of like a doubly linked list, but it is already predefined in the STL, so we are directly using it. And when you say dot begin, it would begin from the very first element inside this edge list object. What do we have inside edge list object? We have edge objects. Edge is our own class, correct, which has two data members, the destination state ID as well as the weight. So when you say vertices dot at I dot edge list dot begin, you are saying this it is basically pointing at the very first vertex, and inside that it is pointing at the very first element, that is of the edge object of the edge list. Okay, 2, so we are looping, right? So we are going from the begin to again vertices dot at I, which is I is again 0, to edge list dot end. So edge list dot end is nothing but the ending element in the edge list, which is this 3,700. So we have two edge objects inside this edge list, so we will start from the very first and go till the very end. This is what this loop is all about. Okay, so we'll go inside this loop. We will check if it dot get destination vertex ID. So it is nothing but a pointer kind of variable which is pointing to the very first edge object inside this edge list, correct? So since it is pointing to this first edge object, because we started with begin, we can access its destination vertex ID by using this user defined function get destination vertex ID. We say if it this arrow dot get destination vertex ID. What is the destination vertex ID of the very first edge object? It is 2. So let's write 2 over here. If 2 equal to 2 vertex, 2 vertex that we have passed is 3. Is 2 equal to 3? No. So then this if block will not be executed. You'll again come at the start of the inner loop, and now it will start pointing to the next object in this edge list. Okay, because there are two objects, remember, in this edge list. So it will move forward because we started with edge list dot begin to edge list dot end. So we will cover all the elements, that is all the objects inside this edge list. So now it will start pointing to the next edge object in this edge list. Again we will come inside this loop. We will check if it dot get destination vertex ID. Right now it is pointing to the second edge object whose destination vertex ID is 3. So is 3 equal to 2 vertex? What is 2 vertex? It is also 3. So now we found a match. So 3 is equal to 3. Now we will go inside this if block, and now this is where we would perform the deletion of that particular edge object. So we will say vertices at I is still 0. Remember, the outer loop is still I equals to 0. So we are still in the first iteration of the outer loop. So vertices dot at 0, which means vertices at 0 means this first vertex, dot edge list means we want to access the edge list, that is this green box, dot erase it. What is IT? IT is currently pointing to the second element, that is this edge object, that is 3,700, and we want to erase it. So erase is again an inbuilt function of the list class which is coming from the STL. Edge list is nothing but an object of type list, so we can directly use this erase function. And when you say erase.it, it would completely delete off this element, okay, which means this element will also be deleted. And let me do that quickly. So this edge object will be completely erased off. Similarly from the visual representation also, let me erase it out. And now what we have done at this line is erased one edge object from one vertex, that is Maharashtra vertex, right? So now we will break, we will come outside this loop, and since the if block was executed, the else if will not be executed. You will come at the end of the outer loop, and again you will go at the start of the outer loop, and now I will become 2, right? Because the first iteration of the outer loop is done. Now I will become 2, so I will become 1, okay, not 2, 1, because I was 0, so I will now become 1. So we did half part, so half solution is done because we erased one edge object from Maharashtra to MP. Similarly, because this is an undirected graph, we also have to delete the edge object in the MP's vertex, because basically if you break down this yellow edge into two edges, because it is undirected, we just deleted Maharashtra to MP, but now we also have to delete MP to Maharashtra, and that edge object is inside MP's vertex. So this is where the else if will come into picture, and now we are in the second iteration, so I is 1. So again we will go inside this loop, we will check if vertices at I this time is 1, which means now we are at the second vertex. We will say get state ID, is it equal to from vertex. What is from vertex? It is 1. Now get state ID, Goa state ID is 2. Is 2 equal to 1? No. So this if block will not be executed. We'll go in the else if block. We will check over here. If vertices at I is 1, vertices at I is Goa, dot get state ID. So state ID of Goa is 2. Is it equal to 2 vertex? 2 vertex is nothing but 3. Is 2 equal to 3? No. So even this part will not be executed. So this if and else if will not be executed. You will come at the end of the outer for loop. You will again go at the start of the outer for loop, and now I will become 2, right? Because 0 is done, 1 is done, now only 2 is left, that is the third iteration is left. So I will now become 2. We'll go inside the loop, we will check if vertices at 2, because I is 2, get state ID. Vertices at 2 is nothing but MP, whose state ID is 3, so you'll get 3. Is it equal to from vertex? From vertex is nothing but 1. Is 3 equal to 1? No. So this entire if block will not be executed. We'll go into the else if block. Over here we'll say vertices at, again I is equal to 2, so vertices at 2 is nothing but MP. We'll say get state ID, the state ID is 3. Is it equal to 2 vertex? Yes, this time 2 vertex is 3, and 3 and 3 is a match. So we found the second vertex. Now we have to go inside the edge list of this vertex, correct? So this is where the second inner loop comes into picture. We'll say IT equals to vertices dot at dot edge list dot begin. So IT will be pointing to the very first edge object inside this edge list of the vertex at index position 2, correct? Because I is 2 over here, so I will be 2 over here also. So we'll say dot begin to vertices dot edge list dot end. Since we only have one edge object inside the edge list, this loop will execute only one time. We'll go inside, we say it dot get destination vertex ID. So it is currently pointing to the single element, single edge object inside this edge list. The destination vertex ID is 1, so you'll get 1. Is 1 equal to from vertex? The from vertex is also 1. So we've got a match. Since we've got a match, we'll go inside the if block. We'll say vertices dot at, which is I is still 2, dot edge list means this edge list, that is this green box, dot erase it. So erase it is nothing but pointing to this object. So since we are erasing this, this will be removed from this edge list. So the second deletion is also done. So now this object will also be deleted or erased off from the edge list. And now guys, you can conclude that this edge between Maharashtra and MP is successfully removed because both edge objects from Maharashtra and MP have been erased. So once this is done, you will come outside the loop. This was the last iteration as well of the outer loop. So this entire if block will be done. You'll come outside, else will not be executed since if was executed, and at the end you can always print out a message that the edge between the two states have been deleted successfully. Okay, so this is how the delete edge operation works. I went a little bit fast because this code is almost identical to what we did in the previous video of update edge operation. The only difference is this one green line where we are doing the erase operation. In the update edge, we were updating it over here. That is, we were adding the new weight. Over here, we are simply erasing it. Okay, so this was the pseudocode and the step-by-step working of the delete edge by ID graph implementation operation. Let's jump to the C++ code and try to implement it and see the program working live. So let's switch to the C++ IDE. Okay, so this is our pre-written code already, and we've typed quite a lot of code. I have basically copy pasted it because I've already pre-written the entire code. You guys can find this entire code on our official website. Please do type it once. Just scroll down to the graph class, and this is where we had the update edge by ID operation. So below it, we will also do the delete edge by ID. Okay, so I have copy pasted the code delete edge by ID below our update edge by ID code inside the graph class. And this is exactly identical to what the pseudocode is. So initially we do the check, then we have the if, and in the else you can print this code that edge between the two vertices doesn't exist, correct? And once done, you can say edge between from vertex and to vertex deleted successfully after the outer for loop. Okay, so let's quickly try to run this program, but before that you'll have to add this code in the main function also. So scroll down in the main function. In the switch case, option 6 is our delete edge. So coming down in the switch case, this is our menu driven program. In the case 6 is where our delete operation is, that is delete edge operation. So this is where we will take the ID of source vertex and ID of destination vertex from the user, and we will say g.delete edge by ID. We'll pass the two IDs. So ID1, ID2 are nothing but integer variables that we've created at the top in the main function. Okay, let's just save this. Let's go to execute, compile and run. Hopefully things would work. Alright, our program code is working perfectly fine. Let's quickly add those three edges first. So option 1 is for add vertex. So the first vertex I will give ID 1 and state name as MH. Let me add one more, ID 2, state name as GA for Goa. Let me add one more, which is 3, and state name MP for Madhya Pradesh. If you want to check all these vertices as well as their edges, the option 9 is for printing, that is print graph. When you hit option 9, there you go, print graph operation. We've got all our vertices and the edge lists which are blank right now because currently there are no edges. So let's add the edges between the individual vertices. For that we have add edge operation. We've already covered that. So option 4, enter the source ID, which is Maharashtra. Let's say the destination is Goa. The weight is 500. So edge added between 1 and 2, that is Maharashtra and Goa successfully. Let's add one more edge between Maharashtra and MP. MP's ID is 3. The weight is 700, right? Alright, so we've created our graph. Again, printing the graph with option 9. So this is our example graph that we were working on our blackboard as well. And now let's say you want to delete the edge between Maharashtra and MP. So you want to delete the entry of 3 and 700 in Maharashtra's edge list and 1 and 700 in Madhya Pradesh's edge list, correct? So this is where option 6 comes into picture, that is delete edge. When you hit enter, it is asking for the IDs. So 1 is the source ID, 3 is for MP. 1 is for Maharashtra. When you hit enter, there you go, edge between 1 and 3 deleted successfully. And now this entry shouldn't exist. So let's do the print graph first to see if actually the deletion has happened or not. So there you go guys, you can see in Maharashtra over here there was 3,700 and now we don't have that entry. That edge object is deleted. But the edge between Maharashtra and Goa is still there. So 2,500 is still there. Similarly in Madhya Pradesh we had only one edge object that is now erased off. So we can successfully say that the delete edge operation has worked perfectly fine. And we have done the practical implementation. Now for the code, I know I copy pasted quite a lot of code because I don't want to waste your time. We've already dry run the entire pseudocode step by step. So you guys can also pause this video and take a pencil and paper and dry run the code or the pseudocode. I have shared the entire code with you guys. You can find it in the video description on our official website. So I'm going to wrap up this video over here. I hope the delete edge operation is clear. We have come quite far in the graph implementation, only a few more operations left. We'll cover them swiftly as much as possible. If you've understood this video, if you like this video, if you like my teaching methodology, let me know in the comments below. Please share this video with your friends, give this video a like, and I'll see you guys in the next one. Peace.